So hello everyone. In this video we're going to have a brief introduction about the gears and the different types and their applications. So the gears are mechanical components used to transmit the power and motion between the rotating shafts. They come in various types, each suited for a specific application based on the design and functionality. The gears usually come in gearboxes as what you can see in this image, and the gearboxes in general are mechanical systems that use the gears to modify the torque and the speed between the power source, like for example an engine or a motor, and the driven equipment. The key applications of the gearboxes includes the automotive, the industrial machinery, the renewable energy, the aerospace, and robotics. The gearboxes are essential for optimizing the performance, enhancing the efficiency, and ensuring that the reliability across the various industries. The gears come in different types, and the most common types of the gears include the Spur Gears, the Helical Gears, the Bevel Gears, the Worm Gears, and the Planetary Gears. The gears can be classified based on the shaft. For example, we can have parallel shafts, or we can have the intersecting shafts, or we have non-intersecting and non-parallel shaft types. So for the parallel shaft, we can have the spur gears, where the shafts are going to be just parallel to each other from the name, and the same thing for the helical gears. For the intersecting shaft, the direction of the rotation between the two different gears are going to be perpendicular to each other, or they can change with a different angle. The non-intersecting and non-parallel shafts are different types, like we have the cross helical gears, or the hypoid helical gears, or the worm gears types. Another way of classifications is based on the speed. So we can have low velocity gears, we can have medium velocity gears, and we can have the high velocity gears. And the other way is based on the gear set. We can have external gearings, where the gears are going to be mating using the external diameters. We can have the internal gearings, and we can have the rack and the pinion. The main four types of the gear are going to be covered in this video. They're going to be the spur gears, the helical, the bevel, and the worm gears. The first type, which is spur gear, is a simple straight tooth gears used for the parallel shafts arrangement. They are efficient and commonly used in the low-speed applications like clocks, conveyors, and machinery. The advantages are inexpensive, simple to design, no thrust load is developed by the gearing, wide variety of manufacturing options. The disadvantage is that it can generate a significant noise, especially at high speed, and are usually restricted to a pitch line speed below 20 meters per second. The helical gears are angled teeth that provide a smoother and quieter operation than the spur gears. They are ideally for the high-speed applications such as the automotive transmission and the industrial machinery. Useful for high speed and high power, quiet at high speeds, often used in low or spur gears for the high-speed applications as we mentioned, but still have the advantage of generate a thrust load on the single phase. And of course they are more expensive than the spur gears because of their manufacturing complexity. The bevel gears are conical shaped gears used to transmit the power between the intersecting shafts, typically in a 90-degree angle. They are found in differential drives, the hand drills, and the marine applications. They have high efficiency, which can be 98% and above, can transfer a power across the non-intersecting shafts. Spiral bevel gears transmit the load evenly and are quieter than straight bevels. The disadvantage is that the shaft alignment is a critical issue. The rolling element bearings are therefore often going to be used for the bevel gears. and this will limit the power transfer for the high-speed applications where the journal bearings is going to be preferable and can be expensive again because of their complexity. The worm gears consist of a worm screw shape meshing with the worm wheel. They're offering a high reaction ratio and compact design. They are usually used in elevators, conveyor system, and the turning instruments. Compact design for large gear ratios. Efficiency can be 90% or higher. Still, the wheel is by abrasion is one of the higher concerns we have with the worm gears. Can be expensive and generate very high thrust loads, and the worm cannot be driven by a gear. The worm must be a driver gear. A practical example of the gearing system is the gearing system that's used in the industrial mixers. The gearing system in the industrial mixers plays a critical role in optimizing the motor performance to meet the specific mixing requirements. Since the motor operates with the high speed and low torque at the low currents, the low speed with the high torque at the high current, the gearing system will adjust this output to ensure the efficient power transmission to the agitators. So by using the appropriate gearing ratios, the gearing system can increase the torque, balancing the speed, and balancing the power. In summary, the gearing system will act as a mediator, translating the motor output into an ideal speed and torque needed for the different mixing tasks, enhancing the mix's versatility and performance. One of the main objectives of the gear design topic is to teach the people on how to design something like a double reduction speed reducer. So the double reduction speed reducer is a gearbox, is a mechanical system designed to significantly reduce the input speed from the motor or the engine while increasing the torque. It's achieved this through a two stages of the gear reductions. Each consists of pair of gears like Spur Gears, Helical Gears, or Planetary Gears of different sizes. So suppose that you are required to decide the design of a double reduction Spur Gears speed reducer, and you need to specify of 4 gears, 3 shafts, 6 bearings, and housing to hold the elements in a proper relation to each other. So, in general, the mechanical design is the process of designing and or selecting a mechanical components and putting them together to accomplish the design functions. And that's what you are going to learn by the end of this semester. The figure 112 represents a conceptual design for the speed reducer. So as we can see here that the first stage, there's an input shaft drives a smaller gear, which is the pinion, that meshes with the larger gear, reducing the speed and increasing the torque. The output of this first stage then will drive the second stage, where another set of the gears further reduce the speeds and amplifies the torque. This two-step process will allow for a much greater overall reduction ratio compared to a single-stage gearbox, making it ideal for the application requiring a high torque and low speed, such as the industrial mixers, the conveyors, the cranes, and the heavy machinery. The double reduction design also ensures a smoother operation, better load distribution, and improve the efficiency. The next video will introduce the kinetics of the gears, and mainly we are going to deal with the Spur Gears design.